Hey guys, what's going on? This is the patch apportionment lab walkthrough video just to get you guys some information on what you need to get through the lab and make your submission if you have any problems. You should definitely have watched the lecture video for this and did the lesson lab exercises as well as the homework. If you did, you should have no problem with this lab. This is part 2 to the malware outbreak lab, where there was a malware outbreak and you had some infected endpoints. So let's look at the mission brief. Follow the malware outbreak analyzed in part 1, like we just said. The organization has received a limited number of emergency security patches that must be distributed fairly across divisions. To ensure fairness and operational effectiveness, the blue team will apply Hamilton's method of apportionment to allocate patches based on division endpoint counts, right? We did some exercises on Hamilton's apportionment. So we know that we have a certain amount of endpoints and they're infected, but we have to allocate fairly the patches, right? So that's what this exercise is going to be about. All the calculations in this course are performed using Python in a Linux environment. Spreadsheet software is not used. In the lecture video, I showed you some pretty cool ways to use Python to help with the calculations of the table. We could even build our own table. You're not required to do that. I even showed you some automation tricks to help with the repetitive parts of the apportionment table, right? So be sure to watch that video. Real helpful for this. Let's look at the instructions. Review the endpoint counts provided in the table. Compute standard divisor, standard quota, minimum quotas, and your final allocations using Hamilton's method. And you're going to record all your answers directly on the PDF. This is a fillable PDF as standard for the labs for this unit. You can fill them out and send them straight to us via email. So for this table, as I said, they gave you everything that you needed. You don't have to create your own table. We know that we have a total of 125 patches available, but that's not going to be enough for all these infected endpoints. If you see, we have corporate workstations, over 5,000 infected endpoints. We have over 1,400 infected endpoints in the finance systems. Human resources has a bunch of infections. The training lab machines, public-facing servers, critical infrastructure, all have a decent amount of infected endpoints. So there's no way that we're going to be able to patch them all with 125 available patches. So to do this fairly, we're going to have to use Hamilton's apportionment method, right? If you don't remember how to do it, I can give you a hint. We have, like I said, all those infected endpoints, and there's an empty box here for totals, right? So maybe we want to add all that up there to see what goes in that box for totals. And then maybe that will jog our memory on how to get these other boxes filled in. So our job here is to fill in all these boxes, right? 125 is the goal. We have 125 patches to allocate. We want to make sure that our final allocations for all these departments totals 125, right? So good luck in there. We do have some help for you in the lecture videos and exercises, but you kind of got to know what you're doing in that table, because the question 1 here is asking you for the standard divisor. What's the standard divisor for this allocation? Round your answer to 4 decimal places. So standard divisor goes in there. If you don't know what the standard divisor is, then it's going to be hard to get accuracy in any of these tables at all, right? So you're not going to be able to really fill out that table without your standard divisor. So that's like a deal breaker with this lab. And they don't let you off the hook that easy, because even if you know the standard divisor, they want you to interpret the standard divisor. That's an essay question. Explain what the standard divisor represents in the context of distributing security patches during a malware outbreak. Use complete sentences and practical cybersecurity terms. So think in terms that you're going to report this to stakeholders. You want to be thorough. You want your sentences to be accurate. No typos. Check your punctuation. Be thorough with it. And in a little tip to help you figure out how to interpret your standard divisor, just think about the 125 available patches that we have and how we have to distribute them amongst the infected endpoints. So what does that 125 mean in that context is how we want to think about interpreting the standard divisor. And we have to get used to being able to express ourselves verbally and written. So we want to write down what we're thinking, how we interpret this. We want to get a couple of sentences to get our point across to these stakeholders. Final patch allocation. You should be able to answer these questions here with the information from this table. But again, if you had any mistakes in this table, then you are going to get errors in these answers here, right? So you want to make sure that you have appropriate amount allocated for your workstations, training lab machines. They're going to get a portion of those 125 available patches, and so is critical infrastructure. So I want you to let me know those three particular departments, what was their allocation, and that goes in those boxes there. Question 4 is a capacity planning scenario. Each security patch can remediate approximately 30 infected endpoints. If critical infrastructure needed to remediate every infected endpoint simultaneously at the same time, how many patches would be required? You want to round to a whole patch. You see this again, round to the whole patch. This is a tangible device that we're talking about. It's a security patch. So we can't have a half a patch. We have to have whole numbers when we're dealing with these available patches. So we're going to round to the nearest whole number. So 30 infected endpoints is the load, right? Each one of these patches can handle 30 infected endpoints. Now, how many infected endpoints do we have? And if we have to remediate all of them, that's where, our thinking is going along those lines. I cannot answer the questions in the lab for you, but I can get your wheels turning and along the right thinking. Every endpoint has to be protected, but you can't have one patch per endpoint. You have to divide them, but you do have a span of 30 infected endpoints that can get protected per patch, right? So go through the notes, look at some of the videos, look at the keywords per patch and all those keywords should jog your memory on how you can get that answered. And then finally, we have our essay question. Usually with these labs, we have an essay question that's relevant to IT classes. That's the point of this whole MAT143 Python course, is to get a relevance in the IT field when it comes to dealing with quantitative literacy. So we want to get the wheels turning in a relevant scenario that you might run into in your coursework. So explain why the organization does not need one security patch per endpoint. Your response may reference staggered deployment, rolling updates, uptime requirements, or operational constraints. Now, I gave those ideas to get your wheels turning because I didn't want a bunch of answers that state the obvious. Oh, well, each uh, endpoint doesn't need a security patch because we don't have enough patches. We only have 125 and we got thousands of infected endpoints. So there's no way that they can get all patched up because we don't have enough. That's obvious. We know that. So we're not going to tell that to stakeholders, and that doesn't sound sensible. So there are methodologies in cybersecurity that deal specifically with this type of situation in mitigation of incident response, right? So let's explain some of these so I can help you out, maybe to get some of the essay question answered. I'll give extra credit to anyone who can give me 5 to 6 sentences, because I'm going to give you some help here to give a better answer than just the obvious. Now, what's staggered deployment? Staggered is pretty much what it sounds like. Not everyone gets patched at the same time with staggered deployment. You have patches that are sent to small groups, not all at once. The thought process here is, you test on a few computers first, and then you send it out to more, right? So that's what a staggered deployment methodology is. Rolling updates is something like patching in waves. Systems stay partly online. Everything doesn't get turned off at the same time. You're thinking of a large company with many users where everything can't be down at the same time. Some departments can experience some downtime, but some of them have to stay up so business operations can continue. That is something that they do in the field. When you think of uptime requirements, you have some systems that must stay on, like critical infrastructure, uninterrupted power supply, security monitoring services. Like, you're thinking you can't shut down a hospital, right? They have patients there that have life monitoring services. You can't shut it down just because you have to patch a server. So that's the thinking you have when you're thinking of uptime requirements. And operational constraints, that's real world limits, nothing you can do to control. Staff limitations. Sometimes you have a bunch of endpoints that need to be patched, but you don't have IT staff support that can patch all of them in a timely manner, right? You just don't have the staff for that. You might have limited time windows, based off of company policies. Maybe the policy says that you can't patch unless it's a night or a weekend, after hours. Business has to operate between these times, so patches can't interrupt that at all. Some companies require that patches be fully tested before they're rolled out. So you have all these things that would affect why patches are implemented the way they are, and they can't all just be patched at once. So that's some food for thought, right? To help you with that question. I'll give you some extra credit if somebody can give me 5 to 6 sentences based off of that. And that's pretty much it for the lab. So that is week 3 lab for unit 1. That's actually the final lab. Next week we don't have a lab. We actually have a unit 1 review, and that's for the unit test. So all the concepts that we've covered so far, we will do a review, and that will be for the unit test. Now, this does follow a traditional MAT143 class, and in that class for the unit test, they had like a team session where you would register for a time, and then you have a tutor that will go over some of the concepts to help you remember things relevant for the unit test. So since this is not an actual class, this is my my capstone project, there's not an actual cohort for this class, so there's no way that I can set up any type of registered meeting where we can do a Teams review for Unit 1. So what I'll do is I'll just record a video that would substitute as that, so it could be similar to a one-to-one experience. You still have a Unit 1 review that will help you prepare for the unit test. Then you would have the unit test, and you would, see how well you do on the test based off of the lecture videos, based off of these lab reviews and walkthroughs, the actual lab experience, the lesson lab website that you had experiences with, the workbook that you had, pretty much all the elements that I provided for this Unit 1 replication of MAT143 from the perspective of an IT student. Hopefully you enjoyed yourself and you actually were able to learn some quantitative literacy from me. Again, I'm not an instructor. I'm a student who graduated with a cybersecurity degree, and this was my capstone project. I had to put together some kind of a project that shows the elements of everything that I learned over the course. And Math 143 was one of the anomaly classes because it had really nothing to do with my cybersecurity, my forensics, my network administration, my programming development, project management. I took all those classes in my coursework. So I had to figure out a way to put all of those elements inside of one project. So what I decided to do there was remake the Math 143 class, which traditionally they just have a class. It's a basic math class that teaches quantitative literacy. The examples are real world examples, no doubt. They go over stuff like unit conversions. If your kid was sick and you had to administer medication, but he was like 48 pounds, but the meds you had to administer in milligrams per kilogram. We do conversions like that. Or are you going to file standard deduction or itemized deduction on your income tax? Can you do an amortization table, a budget? Things that are relevant to your everyday life. That's all well and good, and I appreciated learning that. But as an IT student, I would have wished that they had some scenarios more relevant to the classes that I was dealing with in my coursework. Like especially my forensics class, we had to do conversions between gigabytes and megabytes when we're converting disk sizes and space and allocation spaces and all these things. And I didn't have a relevant math class to support that. Not to mention, I took Math 143 at the end of the course. I didn't even take it at the beginning. I was one of those students that pushed it off to the end. So I got the full perspective of taking all those classes first and then taking Math 143. So it gave me the idea to use this project as my capstone project. And I'm very proud of the way it came out. I feel that is a good one-to-one representation of what you would experience if you took the Math 143 from the school versus the Math 143 from this program. You notice that you still learned Math 143. All the concepts, the mathematical concepts are the same. And with the lecture videos, I hope that you learn a practical way to use Python as a calculator, like to actually, open a terminal, get on the interpreter, and actually use Python to help you calculate through some of these problems with calculative literacy that we just learned. That was the goal. So the problems that we went through, like the concepts, especially with the labs, the malware outbreak lab, the apportionment lab, to where we had to actually apportion patches to the different departments that got infected endpoints, like this lab that we just talked about now. Those are relevant to what we learned in class. Like we had some classes for the SOC analyst program. That was a Sec 160 that we had at the class, and we learned how to use Splunk and SQL and all these different programs to analyze malware and infected endpoints. And what we didn't do was make the incident response plan based off of any type of quantitative literacy analysis at all. So that's what gave me the idea to put two and two together, literally, and come up with this version of the class. So it satisfies for my capstone because the way that I designed the questions. Now the questions have all the relevance to cybersecurity scenarios, IT and networking scenarios, and forensics. The way that I structured the whole project, like the way that I put it together, I used an agile project management scheme that I learned in my project management class. We learned waterfall and agile, so I decided to use agile, and I did sprints, right? So every week I added to the project. The most difficult part of the project for me was the website that I built to replicate the Amplify website that we used in our MAT143 class as extra practice. You know, building that website presentable for a course to teach math was painful to say the least, because I don't have much experience with the web building. But I did take a course, I think it was CTI 110, don't get me lying at exactly what course it was, but that course with Professor Chow, I remember him, he gave us a project to where we had to use HTML and PHP and CSS to build a website to sell some tickets. And you know, that project alone was very interesting, and I was able to use some of the notes from that actual project because I throughout the whole semesters I saved all my notes. I did a lot of projects, so I have these notes and they're relevant to me, and it helped me tremendously to build that website, and I was very proud of that. So everything, all in all, I feel that I was able to use just about every class that I took some way, somehow, in building this particular course. It's funny how, you know, it's just a math class, but I was able to use semesters worth of cybersecurity programming to create the class. And that's pretty much it. This is the last lab in the course. Thank you for taking time to take the lab. I don't want to take up too much of your time on extra stuff, but I did have to give an explanation of how I came about with the idea of the capstone project. So I feel that, you know, this is a perfect opportunity for me to just throw that into this video. And I'm signing off now. Good luck on the lab again. As customary, if you have any problems at all, reach out to me, send me an email, and I'll see what I can do to square you away. Again, thank you, and I appreciate you taking my course.